Hello students, how are you? I hope that you are fine and well. In my previous video I have taught you about the reflection of light. Now I am going to explain the refraction of light, that is also the part of light. So now let's start. As we know that light always travels in a straight line through any medium of uniform density. However, when a light travels from one medium to another medium, it suffers a change in direction. Suppose light travel from air to glass. Okay, so here we should be understand that air is a rarer medium and glass is a denser medium. Okay, so when light travels from the rarer to the denser medium, it suffers a change in direction. Okay, so we can say that, or we can define the refraction of light as the bending of light as it passes from one medium to another is called a refraction of light. It will be more clear by a figure. Suppose here is a glass slab which is represented by G, and this is air which is represented by A. So air is the rarer medium and glass is the denser medium. Okay, when light propagate on this interface, since glass is a denser medium, so it will be bent towards the normal, and in this glass slab, in the whole medium, the velocity will be same. But when the light will come out from the denser to the rarer medium, it will be goes away from the normal. Okay, at the both interfaces it was the refraction of light. Okay, so here we can say that this is the angle of incidence, it is the angle of refraction, it is the angle of second refraction, and it is the angle of emergent ray, and this ray is known as the emergent ray. Emergent ray or emitted ray, and this is incident ray, and this is refracted ray. Refracted ray. Okay, so the direction in which the ray of light bends when it travels from one medium to another depends upon the optical density of the two media. Okay, suppose when a light travels from an optically rarer medium to the optically denser medium, it bends towards the normal. Here at this first interface we can see that when light travels from the rarer to the denser medium, it bends towards the normal. Okay, and in this case the angle of incidence is always greater than angle of first refracted angle. Okay, angle of incident will be greater than angle of refraction. At the second interface, when the light travel from the denser medium to the rarer medium, in this case the emergent ray will be greater than that of the refracted ray. Okay, in the second case, or at the second interface, the angle of emergent will be greater than angle of refraction. Okay. In the whole medium, here the first refracted angle and the second refracted angle will always equal in each other. Okay, and fourth case may be angle of incidence will always equal to the angle of emergent angle. Okay, this angle and this angle both will be equal in each other, and this angle and this angle will always equal in each other. Okay, so these four cases may be possible. At the first interface, angle of incidence may be angle greater than angle of refracted angle. At the second interface, the angle of emergent will be greater than angle of refraction. And in this whole medium, or in this uniform density, the angle of first refracted angle will be equal to the second refracted angle, and the angle of incidence will always equal to the angle of emergent. Okay, so here we can say that the air is optically less denser than that of water and glass. Okay, so we can say when the ray of light travels from air to the water or glass, the incident ray will be bent towards the normal, while when the light travels from the glass to the rarer medium or air, it will be far away from the normal. Okay, and at the both interfaces it forms the refraction of light. Okay, so I hope that you have understood this topic. Thanks and have a nice day.